Okay, so this is a quick video about reflection, and I got so many questions how to find a point that is a reflection through a given line that I decided to make this quick video. Okay, so as you know, reflection is a linear transformation. Okay, so we have to find a matrix M such that M of V, where I'm going to consider V this vector here. Okay, and so this particular point here will be reflected through this line. Okay, so that will be this point here. Okay, all this is more or less simple if we are reflecting the point through the line y equals x, but then a lot of times the question comes when it is y equals 2x or 3x or 3x plus 5, and then everything becomes really a bit more difficult. Okay, so I want to find this, and what I do is I draw the line, and the line is y equals mx. Okay, so I'm going to consider this point here and this point here. Okay, so I'm going to consider this 1 and this m. Okay, so at the end of the day what I have here is vector 1 m, right? Okay, if this is 1 and this is m, using Pythagoras, we know that this 1 is the square root of m squared plus 1. Okay, for any given line y equals mx. So what is the sine of theta? Well, the sine of theta will be m dividing the square root of m squared plus 1, and the cosine of theta or theta will be 1 dividing square root of m squared plus 1. Well, since that is true, now we want to find a point 1, 0, so we take this vector here, okay, considering from the origin 1, 0. So I want to find the reflection of this point through the line. Okay, we are going to rotate counterclockwise, okay, the point 1, 0 through this line. So a lot of times the students ask, why not theta? Because this will be 1 theta and then 2. Okay, so we have to use 2 theta degrees. Okay, so the cosine of 2 theta, so for 1, 0, we will rotate using the cosine of 2 theta and the sine of 2 theta. Okay, so this is the double angle. This is really easy, right? Squared cosine minus squared sine, and sine of 2 theta, that will be 2 cosine of theta sine of theta. Okay, so what is sine of theta? That is, we saw that before, m dividing. We saw it before. Let me rewatch here, right? Sine of theta, m dividing square root of m squared plus 1, right? This m dividing that, and cosine of theta, that will be 1 dividing square root of m squared plus. Okay, so here we are, sine of theta m dividing the square root, cosine of theta 1 dividing the square root. So cosine squared, you just do the cosine squared here, that will be 1 squared dividing m squared plus 1, minus sine squared theta, right? And you get this, 1 minus m squared dividing m squared plus 1. And 2 cosine theta sine theta, it will be 2m dividing m squared plus 1. I don't know if I was clear here. So you pick sine of theta and you put it here. and you square this, and you pick cosine of theta and you put it here, and you square it, you do the subtraction, and you'll get this. Okay, do the same for this one. Okay, pick sine, put it here, pick cosine, put it here, multiply by 2, and you're going to get this value, 2m dividing m squared plus 1. Okay, what about the point 0, 1? We made the reflection for the point 1, 0. Now we do the reflection for the point 0, 1. So that will be a clockwise rotation, because we are coming down now. Okay, clockwise rotation through 2 times 90 degrees minus theta degrees. So that will be sine of 180 minus 2 theta, cosine of 180 minus 2 theta. Okay? Okay, that's sine of 2 theta minus cosine of 2 theta. So the second column of the matrix, this m is for the matrix, will be sine of theta. So you pick this and put here, okay, and pick this and you put it here, and you're going to get this. Okay, so this is your general formula. Your matrix for the rotation will be 1 minus m squared dividing m squared plus 1, 2m dividing m squared plus 1, 2m dividing m squared plus 1, m squared minus 1 dividing m squared plus 1. Okay, so the most common question is, what is the reflection of a given point through the line y equals to x? Because we are for the line y equals x, that's easy, but for the line y equals to x, suddenly everything becomes really hard. Well, m is 2, right? If you just put 2 here, and if you replace every m by 2, you're going to get this matrix. Okay, so this is your metric that will give you the reflection through the line y equals to x. Here I made a quick example. I took the point 5,5 and I want to reflect the point 5,5 through the line y equals to x, and I got the point 1,7. So I took the matrix that we just found, right? And I put it here as a column, the point 5,5, and I got the point 1,7. I hope you understood everything. Okay, so here you have a general matrix. Okay, so if it is through the line y equals 3x, you just replace the m here and you get your reflection matrix. Okay, very quickly I want to show you a process to find a matrix to reflect a vector through the line y equals mx. It's more or less, it is exactly, not more or less, sorry, it's exactly the same, but here we are going to choose another concept. We are going to see this as through bases. Okay, so this can be greatly simplified by choosing a different basis. Okay, so since your line is the vector 1m, so this here will be 1, right, and this here will be m. Okay, and the 90 degrees vector, the orthogonal vector here will be minus m1. Okay, this is for line y equals mx, so you just choose a different basis. Okay, so the matrix relative to the basis 1 of vector 1 over m minus m1 is 1, 0, 0 minus 1 for this line. Okay, so the transformation of 1m will be 1 times 1m plus 0 minus m1, and the transformation minus m1 will be 0 times 1m minus 1 minus m1. So that will be the basis. Okay, and here you do the conjugate. Okay, you put the matrix m here, and here is your A, and here is your A inverse. Okay, and the final result is exactly the same. Okay, but we are just seeing this from the point of view of changing basis. Okay, I will post other videos with some examples.